Thank you. Good afternoon, everybody. Okay, let me see if my eyes are... Okay, this is my presentation. And, well, Stefano said almost everything about the title and about me. And we also experienced SpagoBI during the day because my colleagues talked before me. So there were Virginie and Andrea Gioia who explained to you very well what SpagoBI does as a business intelligence tool. And today we are going to focus on a particular and very hot theme, which is the big data theme. Okay, and okay, so the title says that we manage big data through a comprehensive approach. And this slide shows that in the middle of the picture there is SpagoBI for big data that can interact both with the information building side and the visualization side. Okay, and from the information building point of view, the main concept is to interact with different kind of sources. You can recognize here the most important signatures of the big data ecosystem. You see Hadoop, you see the NoSQL databases, and then we have streams of bytes and also semantic, which we will talk deeply in this presentation. But also, from the information building point of view, there are also features that enabled by SpagoBI to inspect data and to refine the queries and the interrogations over these sources. On the visualization point of view, we have many different kinds of visualization tools that, according to the type of data that you have to represent, can work together to provide a full and complete representation of the data. So the first concept we are going to focus is the concept of dataset, which is very important, and it is an independent object inside the SpagoBI server architecture that collects data from different sources. So it retrieves data and is used by the visualization tools to represent what the dataset has retrieved. The dataset that is then can be persisted, so this is a need when we are talking about big data because, well, of course, maybe it's better to store somewhere the aggregation that maybe can take a lot of time to be extracted, to be created. So the aggregation over Hadoop, for example, or a Hive, which has got a high latency, can take much time, so it's better to schedule, and you see here the icon of the scheduling, and then can be persisted over database or in-memory supports. I'm sorry that there are some strings that are not well formatted, I don't know why. Anyway, data sources is the first scenario that we're going to see, and this is the most typical. We are approaching different kind of sources. We have the Hive data warehouse for Hadoop, and then we have HBase, which is the database for Hadoop. So all of them are a part of the Hadoop ecosystem. And then we have Cassandra, which is an Apache project for column family NoSQL databases. Then we have the Cloudera Impala, which is a query engine for accelerating the queries towards Hive, but also HBase. And then, well, we put here a kind of NoSQL database, which is, for example, Neo4j. And the database component can, of course, connect towards these different sources and collect data from them. Using different kind of languages, of course. There are all SQL-like languages. Every driver has its own implementation. We have, for example, CQL for Cassandra, Cypher for Neo4j, and we support this kind of queries over these sources. And of course, then the database, I'm not going to repeat it anymore. You will see there in the corner in each slide, the dataset is used then for representation. Okay, another scenario is the emotion data. So we are also facing continuously running data. So streams of bytes coming from the social, typically coming from Twitter. And so suppose you have a spout, which can be, for example, Twitter, as we said, that is, and these streams of tuples can be collected and processed by stream processors as I put here Apache Storm, which is an open source project for processing streams of bytes and in topologies, or also using complex event processors for distributed environments. And at the end, or in the middle of these topologies, or let's say an important part of the processor can be the SpagoBI adapter. The SpagoBI adapter is a component that notifies the SpagoBI dataset of the newly available data, so that you can represent data with some different kind of engines and of documents, of course. Another theme that I would like to underline is the semantic data. Most of all because it happens very often that you have to manage with big data unstructured data, data coming from different sources, from different scenarios, and you want to categorize this data, you want to classify them. So it's better to use maybe domain ontologies and annotations, so RDF annotation, you can think of these predicates to identify the concepts and the issues and the items, the entities, let's say, of whole representation. So you can use, typically you can use graph NoSQL databases with or without SparkQL plugins and so on, just like Neo4j, but also OrientDB, which is an Italian graph database with partly document-based and partly graph database that can store this kind of information. So also linked data can be stored in this kind of databases, NoSQL databases, because these are especially made for distributed environments, okay? So then the dataset can collect data from these sources, these repositories, with JDBC connections. So they all provide the JDBC drivers. And that it can produce a new kind of representation, which is a network representation. This is based on cytoscape. And so you can produce all the networks with the colors and the features that you want. And this kind of report can be used to filter data. So each of the edges and each of the vertex are clickable, let's say, so you can select one of them to see the relationship. You just maybe want to filter over a relation for data that is stored somewhere else, that are stored somewhere else, or for a particular entity, a particular classification, so that you can just use it as a filter or just as a representation of data coming from these graph databases. Let's go back to the information building, what I was saying at the beginning. So what do we mean for information building? You see that in the middle there is still the dataset concept, which manages all the connections. And you can see that it can connect, it can use different kind of sources this time. So information building can be made using files, comma-separated value files or Excel files. So end user data, in this, Virginie told you about this behavior, but also data sources that we saw in the previous slide, so big data data sources, or even already made data set. So you can perform ad hoc reporting over these kind of sources, and then you can produce visualization that can be used once again to come back and to refine your analysis. Okay, so through the query by example engine, the cooperation of these tools can provide new information and can supply new value. So this is the life cycle of information. This is just nice picture to show you what's the cycle that this information can do. So suppose you start from big data sources, suppose these are storages, NoSQL storages, then you can create a data set over this, so a query. You can just imagine a query. And then you can produce a worksheet, so a visualization directly over this data set. So the end user can produce this, or even the developer can produce the first analysis, the first visualization of data. Then if it is not satisfying, you can go back and through the query by example engine, you can refine your analysis. And then you can save it as a new data set that can be then stored or persisted on databases or in-memory supports. But you can also start from the data set and directly execute new aggregation through the query by example engine. So this is our query by example engine. This is a screenshot. And it's also a tool for self-service BI. We mean self-service because the end user can perform its own analysis over its data. So you see here we have the comma separated value file, but also data sources, data set, and in a graphical and smart way, it can produce queries and aggregations over data. And then directly connected to this tool, there is the ad-hoc reporting engine, which is developed through our worksheet engine that provides an instant graphical meaning to your data sets. So what does it mean? That you start from a data set that can come from whatever source you have experienced, and then you can just, with some drag and drops, you can produce your analysis. And then you can also think about what you are representing. So if it is the correct way, if these are the correct data, or if you have to go back and refine everything and do some more steps to produce your information. And last but not least, we suggest the usage of the dashboard engine. So the dashboard is a composition and aggregation of different documents. You see here, these are documents coming from different tools present in SpagoBI, and they can be put all together in a single view to provide an instant information at a glance, let's say. So the documents can interact one with each other. So you see the blue arrows. So they can also interact and they can filter the data of one document to the other. So they can cooperate together to give an information and a deeper insight of data. Okay, just a use case, I would say, because we faced this use case in our real experience. So it is the use case of telecommunication companies which have big data coming from mobile data traffic, and they want to produce new value, maybe to improve their services or create new solutions for their customers. And we experienced that putting them together with open data coming from public administration, for example, highway traffic, voice traffic, consumptions, and so on, we can supply new values. So mixing in the proper way this data, aggregating data together can produce new value. So this is just a picture showing what's the information cycle, just to summarize that it is the cooperation of the tools that we provide with SpagoBI that gives the value. So you have a cycle coming from data to visualization. And then what comes next? So this is the challenge. You see in the bottom all the pieces of a scattered puzzle, let's say, they don't seem to mean anything. They are unstructured. Maybe they seem not to be the same things, so you don't know how to treat them. But using data mining, text mining, sentiment analysis, predictive analysis, and all of the new kind of analysis that are coming, and you can think about tools just like Mahout for Hadoop or R for distributed environment. Well, you can mix them all together. You can compose these pieces of the puzzle to get a value. So here you see in the top of the picture a Mondrian picture which shows how it is possible to aggregate something that is not meaningful to produce something meaningful. So this is the end of my presentation. I thank you, everybody. Here you can see all the references to us. Thank you.